So moving on with the component level review of my motor drive, which I'm designing. This is the block diagram of this motor drive, and this is the schematic here. Next on the list is the LCD connector, and as with the other connectors to which I have assigned pin socket, let's see, the pin socket footprint. I'll just change to this list here. So the LCD connector has a pin socket footprint, which is incorrect. My intention was actually to use a shrouded connector, and we're going to double check that this one is a shrouded connector. Code. Shrouded means that it has this plastic cover surrounding all the pins, and shrouded pin headers are also called IDC headers, and we're going to have to update the footprint to use an IDC header. So this is a vertical IDC header, and the footprint has to reflect that as well. So I'm going to update this component in my library. And make sure that this one is using the correct footprint. This would be connector IDC 2x8 254 vertical. All right. Next on the list, I think we can mark this as done. One thing that I'm going to do here, though, is make sure that this entry is going to be updated, because I don't know why the datasheet URL got underscores instead of being like a normal URL. So maybe it was something that got in there before. So I'm going to make sure that when I run my update script, it's going to update all the fields from Mouser, and hopefully we get the proper datasheet URL there. Next on the list would be, let's see, oh right, so also the LCD connector, in terms of the footprint for it, it could be actually a good idea to make sure that this footprint, right, I'm going to annotate this footprint, and to do that I'm going to have to copy it to my own library. Let's see. I should actually be doing this with every single connector. So I'm just going to update this one to be custom con LCD. And then go to the footprint editor. And then we're going to make sure that we have texts here. So we can start here. VCC. There. And I think this one's GMD. I'm gonna move them in place a bit later. First, I'm just gonna. Actually, one is GND. The second one is VCC. So this will be like this. Move that one there, and then number 3 is. Let's see. Move this maybe here. Number 3 is VO, and number 4 is data. Doing this kind of annotation in the footprint makes sure that I don't forget it later. Let's see. And then we have the reader, and we have the M, which is 6, and we have the D0, which is 7, D1, 8, and D2 is 9, and D3 is 10, and D4 is 11, and D5 is 12. 12, come on, what happened? 5. There we go. And D6 is 13. Let's see. And D7 is there. Why does it disappear? Like, what am I doing wrong here? Sometimes I don't get the text on the footprint after pressing enter. That's interesting. And this would be lead plus 15 and lead minus there. Oh, I see. So they got placed there instead. Let's see. Delete. Okay. Can we make this equal spacing maybe? Let's see. Place. Align. Distribute vertically. Good. And align right. Good. Although I think that this got a little bit messed up here, because if we place this, yeah, it kind of got messed up. Maybe if I move this one, let's see, if I move this one in place and then select all of them and then do distribute vertically, then I would expect that it will distribute the others. Yes, that's perfect. So I have to place just the first one and the last one. So this one. Yeah. And then if I select all of them, I can distribute them vertically and align to the left. And distribute. Excellent. Okay. And then we can just move this a little bit to the side there, like that. All right. Excellent. So we got this one annotated. Would it be a pretty thing to do to add like a table around this? I don't have time to do that. So I'm not going to do that. Okay, great. Yeah, so I'm going to close this one, and just going to make sure that let's see, update field values, and make sure that this one has LCD, con LCD. Great. Excellent. Next on the list is UX, which we are also going to have to annotate. So I'm going to just make sure that we have a custom footprint for this connector. Let's see. Vertical, KiCad mod. So I copy the IDC header 205 to my custom folder and call it con.ux. So what I can do now then is exactly the same thing that I did with the other connector, with the LCD connector. I'm going to go to the UX connector, and I'm going to open it in the library editor, and I'm going to update its footprint to be custom. Let's see. Footprint could be custom con UX. And after I've done this, I will go to the footprint editor and I'll edit that connector and add the annotations. So con UX. And we'll just do the same thing as with the LCD connector. Let me just move this to the side here, like that. And then I can have the text here. So it's 3v3. We should also, let's see, I think it's 500 milliamps. I wonder if this is going to be too much text, so I think that we'll do like this instead. So move that one there, and then let's just annotate all of it first. So G and D is number 2, and number 3 is TX. Number 4 is RX. Number 5 is SCL. And SDA. And 7 is MISO, MOSI, great. And number 9 is SCK. And then number 10 is CS. I wonder if this works. Yes, that works too. Great. Let's double check this with the UX connector pinout. UX interface is created by Olimex, which is an open hardware company, which uses this connector on their boards. And they have several extension boards that plug directly into the UX connector, so it's nice to kind of use the same layout. And I think it's a pretty functional interface. I like the idea of exposing I2C, UART, and SPI. And the biggest benefit here is also that I have those pins connected to the STM32 in such a way that some of them can be remapped to be of a different functionality. So I can, for example, if I'm just using the SPI pins here, I could remap one of the I2C pins to be an interrupt pin. So it's kind of flexible, and that's very nice. So let's just see here if we have the right pin out. So it's 3v3 ground, TX RX, SCL SDA, Misomosi, SCK CS. Awesome. So now the last thing to do here is just to align those text boxes here. So we can start by moving this 3v3 to be aligned with the pin number 1, and SCK is going to be aligned with pin number 9, and CS as well, pin number 10, and the GND with pin number 2. And then I can just select this and do, no, selected too much, and do align distribute, align left, and distribute vertically. And then this one will be aligned right, and distribute vertically. Great. All right, so yeah, one more thing. We can add a little bit of text. Max, let's see, I think it's 500 milliamps. And we can also set this to UX. And the reference can go there. So, great. And I'm going to update field values, and I should see con UX, and yeah, everything is nice. And just the same thing here. Maybe this is the way that the datasheet is returned by the Mouser API. I don't know, but I'll just sort of remove this. Let's see, where can I? Oh yeah, of course, because I have to do that in the library editor, which I think I've done already. I'm just gonna double check. No, I haven't. So I just remove that field so that my script then updates all the fields for this component. Okay. So that's it for the UX connector. And next we have encoder connector and a motor and Hall sensor. Let's see here. So encoder is 1 times 8. And that is also, so this has to be a horizontal connector, not a vertical one. So we have to check that. Let's see. It looks to me like the YouTube video is of extremely bad quality, at least what the YouTube is sending back to me. So we'll see how this turns up when it's all processed and recorded. So this one is a horizontal one, that's good. 8 position and 3.5 millimeters. And then let's see, yeah, horizontal there. Great. Right, so what I want to do now is copy this terminal block to my custom library so that I can label it. So I'm going to go ahead and do that. Let's see. We have terminal blocks 1 times 8, 3.5, vertical. I'm gonna have to edit this this footprint just like I did with the other terminal blocks. Can't really reuse the changes that I did to the other terminal blocks because this one has 8 pins. And this was a footprint that looks like that, which is kind of not what I wanted. Let's see. I wonder if it would make any sense to... Okay, actually what I'm gonna do is I'm just gonna modify the footprint for the footprint that I copied. But what I'm going to do is go to the datasheet for this component, and I'm just going to create, I'm just going to make sure that everything is according to the datasheet for this particular component. So we can remove all this crap, like all the graphics, which is kind of annoying. Let's see. Can we remove through pins? And text, no. We can hide the fab layers. Yeah, and courtyard as well. Yeah, great. So now I can just select all of this crap and remove it. No! You gotta be kidding me. Okay, maybe I should just remove that. Okay, come on. Please don't select stuff that I don't have visible. Please no, KiCad. Don't do this. This is bad. Come on. I don't want to select the pins. God damn it. Maybe I can do like this. Okay, if I do like that, then I just select kind of all of the... it only selects stuff that is within this rectangle, so I can't really do like that. But I'll have to just go over each one of these lines and just delete them manually. And I can't even click on it. Come on. There we go. So delete that one, delete that one, delete that one. Delete that one, delete that one, and that one, and that one, and that one, that one. Okay, I could maybe make the job a little bit easier, but only marginally easier. And that one, that one, that one, come on, that one, that one, and that one, and that one, and that one, and that one, that one, that one, and that one, and that one, and that one, and then all of these little lines here. Let's see. Okay, that went easier. And I can show all of the layers again. And have through hole pads. Right, no, actually, I have to delete stuff from the fab layer as well. Well, that worked better. Okay. All right. So let's show the through hole pads, and then let's modify this to be, so let's see. If I just remove those through hole pads and I move this thing, let's see, what will be a good way to do this? Maybe I can just move that part first and then just align everything else to it. So if I move this line like that, let's see. So this has to be placed at around 1.2. Yeah, it's pretty much like really close to the pins. So I'm not going to place it at 1.2. I'm going to place it a little bit off, and then I'll place. So it's 9.2 in length. And this one is 6.6. So what if we make sure that this is like if we make this 6.2, then we got 3 millimeters sticking out. It's better to have 5 millimeters, yes, because there can be some space between the casing and the sort of the outside edge of the casing. So let's make this. Let's make this 4. So 4.5, because we have moved this a little bit. So okay. So if this was starting like, what we can do is like this. So the end point is minus 2.3. And we can make this 3 instead. Actually, no. Wait. So this would be 2.3. This is x, and this would be 3, like that. So this would give us 3 millimeters here, and then 5 millimeters to the. Let's see. Yeah. Okay. And then 5 millimeters of the connector is sticking out of from the PCB edge, which is exactly what I want in this case. I'm going to place this here and then this here. And then I will move this line here. And I'm going to remove that crap. And we can also make this, place this here. And the courtyard is going to also be moved. Let's see. Let's move that one and rename this to Encoder. Damn it. Can I move this? I have to press M to move it. Because I didn't want to move just by holding and dragging the mouse. Okay, and then I'll just update these ones here. Actually, that's wrong. That's a little bit offset there. Maybe this is just misaligned. So yeah, it's misaligned to my grid. That's basically what the problem was. So I'll align it to my grid, and I'll move these ends in place as well. Okay. And the last step is, of course, to annotate this. I think it would be -90. Let's check also the schematic for the pinout of this. So we have encoder here. Okay, I'm gonna cancel that, and I'm just gonna move up to the encoder here. Where is, let's see, there, that connector. Okay, so then I'll just move it like this. And we can just say that this would be A, and then A inverted. I think we can go with -90. No? +90. And let's see if +90 is kept throughout here. No. So I have to go like this. Let's see. And then it's B like that. And Z and Z. Wait. A, B, C. Yeah. Okay. Let's make this 5 volts. And G and D. And I'm just going to align the G and D here, and then I'll execute the alignment function after I've also just rotated this. So it's easier to rotate them after the fact because it kind of saves clicks. Okay, and just maybe I'll move this one a little bit. Yeah. Okay. And I'm such an idiot because I placed them in the courtyard layer. Oh my god, come on. Maybe I can select all of them like this. And no, I can't edit them. Okay. Front silk screen. From silk screen, and this one as well, and then this one as well. And I'll move the reference out a little bit here to the side. Or maybe like this. Yeah, actually the reference can go there. The reference is going to be moved probably anyway once I have placed this on the PCB. Align, distribute. Align to bottom, and then distribute horizontally. Yeah, looking good. And what else can we, let's see, max plus minus 40 volts. And this one is max. Yeah, we don't need to say the max value there. It's maximum 900 milliamps, but that's for everything that goes to this power supply. So we can just sort of draw a line here. Or actually, no, this is not necessary. That is going to go into the technical manual. This connector is not going to have that level of detail. All right. So it should be all correct here now. Update field values, and we have encoder, Encoder, and then yeah. Great. So now we can greenlight the two encoder connectors, which is this one and this one. Great. And it's going to be pretty much like a very similar so for the HAL connectors, I've used Mets Connect footprint, which is probably wrong, but I'll check because this is supposed to be 1 times 5 of the same type as all of these. Let's see. Let's check this first and make sure that this one is a horizontal one, not a vertical one. Yep, this one is horizontal, 5 position. And the data sheet is going to be pretty much the same, I think. It's probably going to be the same data sheet. Yep. But what I need to do is I'm going to copy actually terminal block for Yukon of the size 1 times 5, and then I'm going to modify it in the same way that I modified. Let's see. Or actually, no. What I'm going to do is I'm going to take the encoder connector and I'm going to just remove some pins on it. That's much easier. see here. Yeah, by the way, yeah, first of all, I'm gonna open this. Let's see. First of all, I'm gonna modify this to use the new footprint. 1, 2, 3, 4, 5, and then the footprint is going to be custom con. Great, and then I can move on to the footprint editor, and I can annotate this connector. So we have con hal, and we just remove the pins here. Okay, and then I'll just move this line. Let's see. Maybe we can just make this a certain length. This should be, according to this, it should be 3.5 3.5 times 4 plus 2.45 times 2. 18.9. Let's zoom in here. So 18.9. So I'm looking at the length there. So 18.9 there. I just need to make sure that it's aligned there. Let's see. Come on. Just one more. Okay. It's not aligned with the grid, so it's a little bit off there. So I'm gonna just make sure that it's 18.9, and I'm gonna align the other side of it so that it's aligned with my grid. Like that. Okay. Well, that kind of makes sense. It looks like it's aligned. Let's see. I'm gonna move this one here, and then I'll just move the layers to follow this. Let's see. Can I get this one here? That's good. And this one over here. And then I have this one up there. Let's see. So this one is also misaligned. I think I need to update this. Okay, cool. We have con encoder. We have the reference. I think I actually moved this. I think I need to move the other end of it. Let's move the other end of it. We should be able to align this other end with the grid. Like that. Okay, this seems good. And then we have this line, which goes, I'm going to align it in a bit. Let's see. The courtyard. Okay, is that aligned? Yes, it seems to be. And then this one, and then is that like, is that similar size? No, it's a little bit too wide here on this side. Move it here, and move that in there, and then I'm gonna line this once here. seems good. And then that one go, that will go as well, and that one too, and that reference will go here. And let's see. Come on. And it's going to be called obviously conhal. And it will have, let's see, ABC 5 volt G and D. So this will be B, C, and then 5 volts, and G and D. And just let's make sure that they're all aligned. Bottom. Yeah, and that's actually a bit better. In fact, I can move this even closer to the silk screen. That makes things easier during the layout. Save this one, and then I want to also update the encoder as well. So I'm going to just move this. So the connector itself is not going to stick out past the silk screen, and the courtyard is only for having a little bit of distance from the connector, so we can have the silk screen as close as possible to the silk screen. I'm going to save that one, and close that one, and then update field values. And this one should be updated to conhal. Great. All right. So that's it for this video. And I just have the motor connector here, which I'm going to review in next video, and then I'm going to move on to the MOSFETs and resistors. And then after that we have, let's see, we have some buttons. Test points can be done pretty quickly, and then the bulk of the work of reviewing is on the ICs. So this is going to take some time, but it's very valuable to go over the schematic in this way. Because as you have seen in all these review videos, many issues are discovered and fixed when doing a detailed component level review. I hope you learned something, and until next time.